Hello, I'm Raymond Hoofs. I'm sorry, first of all, for my voice for this recording. I have a bit of a cold. But I'm from ESA, I work on the Rosetta project. I work in the European Space Astronomy Center in Madrid, from where we operate Rosetta. And I'm going to talk to you about Rosetta, about the mission, and about the planning of the operations. And I will show this through some slides in a presentation. For the landing site selection, a strategy was in place to select 5 areas initially and then analyze them in more detail for a final selection down to 2, being a main landing site and a backup landing site. So areas were selected on the head of the comet and on the main body of the comet. And after a lot of consideration, the landing site J was selected as the main landing site and C as the backup landing site. There was a strong preference that the landing site J would work right from the beginning, because a replanning and going to the backup landing site would mean a lot of operational work again, plus a delay, of course, of the actual landing. Before we go to the actual operations for the landing, I would like to give an overview of the characterization phase of the comet, which resulted in the images that I showed of the actual comet. But very important in this characterization phase is to characterize the gravity field of the comet in order to fly closer to the comet every time, and in order to do this very precise landing that is needed to put the lander at exactly the right place. So in order to do the characterization, the spacecraft would fly triangle-shaped orbits, and every time when it flies a triangle leg, we would see how the comet is pulling the spacecraft and how the gravitational forces are working on the spacecraft. And with that information, we update our gravity models. Once we have enough data to go really closer, we will try to go in orbits around the comet. This can be done from around a distance of about 30 kilometers. And now we start orbiting the comet in the so-called terminator plane, which is the best area to observe the comet from the navigation point of view. From the 30-kilometer orbit, we will try to go to 20-kilometer orbit, which we managed to also do, and then go into a 10-kilometer orbit for the real detailed observation. The landing site selection is already done before we go into the 10-kilometer orbits, but we do the close orbits to continue verifying that the landing site that we have selected is a safe place to do the landing, or at least the safest place that we could find. On the comet, special orbits had to be flown. First, we show again the close orbits at the 10-kilometer distance. Then to do the actual landing, there was a dedicated orbit in order to do the correct phasing with the spacecraft and the landing site. This was the pre-delivery orbit. And then from the pre-delivery orbit, we would make the landing separation maneuver, during which the lander would get separated and the spacecraft would fly out to an orbit where it would provide excellent communication to the lander. So this was one of the most difficult maneuvers that had to be done with the Rosetta spacecraft. Also, there were a number of maneuvers in a row without being able to do the orbit determination. So it's Technically, it's very complex. And once the lander was separated, the spacecraft would actually point to the lander and make mosaic observations around the lander in order to see the lander as it was falling down to the comet. So these observations would show that the lander was in a good state, and it would show that it was going also in the right direction. So we would be following the lander with the spacecraft right up until the touchdown of the lander on the surface of the comet. Just after the lander was separated from the spacecraft, the lander also took a farewell image of the Rosetta spacecraft, which provided a very nice view. And the observations from the spacecraft of the lander showed very nicely that the lander had deployed correctly, had a slight spin to it as was anticipated, and was falling down toward the comet. The landing site itself, although it was selected as the best spot for the landing, was not an easy spot to land at all. It consisted mainly of terraces together with cliffs. So the aero ellipse was also quite big, so there was the chance we could not hit directly the flat surface. Nevertheless, we were of course aiming for this exact spot. We were targeting this spot, and we could see that we were going in this direction with cameras that were on the bottom of the lander. So we have a picture of about 3 kilometers above the surface, and then another picture of about 40 meters above the surface, made by the lander. Then we have again the images from the orbiter taking the pictures of the lander, and we could see the lander flying now over the comet surface, going to the touchdown point. Unfortunately, we could also see that the lander did not stay at its touchdown point, and we could actually see that it bounced off the comet and was flying in another direction again for another landing on the comet. So of course we got the pictures of the lander after we actually got a direct signal from the lander. And when the lander was going for the touchdown, the first touchdown, we already found that the lander was not providing us the signal we were expecting. So already then we knew that the lander did not stay in the position we expected, but we did not know exactly what was going on with the lander. So we see again the aimed touchdown point, that indeed we did touch down, and we can see the footprint of the lander legs. And afterwards we managed to analyze the trajectory of the lander over the comet surface, and it actually made 3 landings. So it had a flight over the crater on the head of the comet, then there was a second touchdown point, and a final touchdown point in a rather dark space on the comet. For some lander instruments this was good, as they could get data from multiple regions of the comet, but also for some instruments it was not so good, because we landed in different circumstances than we expected. Detailed images were taken of the final landing site in the hope to actually see the lander visually. We knew the location quite well because of radio signal measurements that were done, but we never got a very good shot visually of the lander. So this dark area where the lander landed would get more illumination as the comet would move to the perihelion, and there was a good chance that the lander could get sun on the solar panels later in the mission to continue an extended mission for the lander. Nevertheless, for the nominal mission of the lander, the batteries were charged to do 2.5 days of science on the comet, which the lander did very well. It was able to communicate perfectly to the spacecraft and do all the science measurements that it needed to do to achieve its scientific objectives. So the mission of the lander was already a big success. But we were of course hoping to also have a bit of extended lander time at a later stage at the comet. Here we see the image of the panoramic camera of the final landing site, where we see the lander in a very rocky surrounding. We have a artificially colored image showing a bit of depth into this rocky environment, which shows quite a spectacular cometary landscape. After the landing operations were performed, the Rosetta mission would continue as the comet would travel towards the sun and then away again. Very spectacular observations were to be expected as the comet would get more active. The scientists, they found a very complex morphology on the comet, which allowed them to divide the comet in several areas with different geological structures. There is the region around the neck of the comet that showed very strong cliffs, and then in the neck itself it showed a lot of boulders. Of course, there was a very interesting gravitational field in this neck region, because also the center of gravity is in this area. So how gravity works in this region is quite complex. We could also see that the comet activity was quite well present from these neck regions. And we took some detailed images of the so-called Imhotep region, which is at the bottom of the big lobe of the comet, which it shows a big, let's say, flat field with some big boulders. Some detailed images were taken of these big boulders there. And we have a lot of detailed images of the different plateaus that we see on the comet, and how we see cliffs collapsing on the comet. And it's all being analyzed on how these formations are formed and how they relate with the comet activity. So the comet activity, we could clearly see it coming from the neck regions already very early in the mission. Here a picture of February 2015, still quite far from the sun. And we see jets coming out of the neck region. As we get closer to the sun, we see the activity increasing, and also at this stage we noticed with the spacecraft that the star tracker performance gets more difficult because of the dust environment, and the spacecraft needs to fly a bit further from the comet in order to be able to do proper attitude determination. The activity of the comet becomes quite spectacular in the time of May and June, with some very impressive images. The activity at perihelion we see a further increase, and we also start seeing some very violent outbursts where a lot of dust and a lot of material is ejected in a very short period of time. So we observe very clearly these ejections of material from very localized spots on the comet. And these ejections of material now form very bright observations, being sometimes brighter than the comet itself. The scientists are linking the activity to surface features, mainly the pits that we observe at the comet. So these are deep, round pits which seem to be collapsed areas. And we also see clearly that sometimes big particles are ejected. So these are basketball-size particles that are ejected by the comet into space. We see them in this image coming from the walls of the comet as soon as the sunlight hits these walls. So it's something that we will continue investigating. And when the comet is flying out again now, we hope to get much closer with the spacecraft again and look at these regions where this activity has taken place and analyze the differences that we see there now after this activity. At the moment, the spacecraft is on its way with the comet again to the outbound leg. The spacecraft is now flying along again with the comet, going into the deeper regions of space. We're still just past perihelion, but the activity is now expected to slowly go down. We expect to get closer again to the comet as the dust goes down along with the activity. And we hope to do again detailed observations of the cometary surface towards the end of the mission. Then at the end of the mission, we at the moment are developing plans to go and fly very, very close to the comet. There are also plans to land the Rosetta spacecraft on the comet at the end of mission as well. But these are being discussed at the moment, and please continue following the Rosetta mission and you will see the final plans for also a spectacular end of a spectacular mission. Thank you.